My dear students of 11th Science, welcome back to DB Sir Physics classes. In my previous physics class, we discussed there about the elastic potential energy of a spring whenever a spring is elongated or compressed. The expression for elastic potential energy of a spring whenever the spring is elongated or compressed is U equal half k x square, where k is the spring constant of the material of the spring and x be the extension or compression of the spring. Today we want to plot the graph of potential energy, kinetic energy and total energy of a spring whenever a spring is elongated or compressed, for which see the diagram on the board very carefully. Now in figure 1, A is the normal position of a body whenever the spring is unstretched position. In figure 2, the body will pull from point A to the point B, which we consider the right extreme position of the body. Okay, and for this position, the extension of the spring is x. So therefore, for the position B, the potential energy of the spring is half kx square and the kinetic energy of the body is 0. So therefore, total energy of the system is 0 plus half kx square, that is half kx square. Now, if we release the body from the position B, the body return back to the positions A with some velocity, and at the position A, x equal 0, that's why potential energy 0, but potential energy of the position B is converted into the equivalent amount of kinetic energy at the position A. So therefore at the position A, the kinetic energy is half k x square. So therefore at the position A, the total energy is 0 plus half k x square, means half k x square. Now the body pass over the position A and reach to the point C, which is the left extreme positions of the body, where the compression of the spring is x and the velocity of the body at the position C is 0. So therefore kinetic energy at the position C is 0, but the potential energy here also is half k x square. So here the total energy is 0 plus half k x square, means half k x square. So therefore from this explanation we can say whatever may be the positions A, B or C, the total energy of the system always remain constant, that is half k x square. Now see the graphical variation of these three types of energy. Just see the graph. A be the normal position, this is the right extreme position, this is the left extreme position. At the right extreme position B and the left extreme position C, the potential energy is maximum but the kinetic energy is 0. So that's why the blue graph is here for the potential energy, which indicate that at the two extreme position the potential energy is maximum but at the normal position the potential energy is minimum. The red graph is for the kinetic energy, which indicate that at the two extreme position kinetic energy is 0 but at the normal position the kinetic energy is maximum. And the green graph is for the total energy, which is always constant, that's why it is a straight line, which is the sum of kinetic and potential energy. Now student, during the oscillations of a body connected with a spring, one thing you have to remember that if Vm is the maximum speed and Xm is the maximum displacement of the body, then we can write an equation half m Vm square is equal half k Xm square. From here half of cancelled, so therefore Vm is equal root over k by m into Xm. So by this formula we are able to determining the speed of the body which is connected with the spring during the oscillations of a spring. Clear? Now during the extension or compression of the spring, From our previous class, we know that there will be a restoring force acting on the spring. Okay, so student, you have to know the variation of this restoring force with the extension and compression of the spring. Now see the situation very carefully. When x greater than 0, x greater than 0 means the length of the spring is increases. Then the restoring force acting on the spring is negative. Whenever x less than 0 means whenever the spring is compressed, then f greater than 0 means the restoring force acting on the spring is positive. And whenever x is equal 0, there is no extension or compression of the spring, the restoring force on the spring is 0. Okay, and this is the graphical variation of the restoring force with the elongation and compression of the spring. Okay, now see the graph very carefully. A portion of the graph represent, that is a restoring force acting on the spring whenever the spring is elongated. The graph OB portion represent that this is the restoring force acting on the spring whenever the spring is compressed. And the point O represent that whenever there is no elongation and compression of the spring, then the restoring force is 0. Now student, regarding this potential energy, you have to remember that elastic potential energy of a spring either be positive or be 0. Either be positive or be 0. Just see at any position, if you see over here, the potential energy is positive or 0. But gravitational potential energy may be positive, negative or 0, which we can explain from this relation. Potential energy is equal negative of work done. Negative of work done. For example, we just throw an object vertically upward. Then the work done by the gravity is negative. So as the work done is negative, from these relations we can say the potential energy is positive. So means here the potential energy is positive. Now whenever a body falling downward, falling vertically downward, so then the work done by the gravity is positive, means the potential energy is negative. And whenever any object is situated on the surface of earth, then the potential energy is 0. After knowing this concept, student, you have to know a very important concept known as equilibrium. We have to know about the equilibrium. Okay, now see, a body is said to be in translatory equilibrium if the net external force acting on the body is 0. That's why I write over here F net is equal 0. Now if this force is conservative force, then from the relation between the conservative force and potential energy, we know that F equal minus du by dr. As for equilibrium, the force F is equal 0. From these equations we can say du by dr equal 0. Means the slope of your graph is 0. Means for a body, whenever potential energy versus position graph is given to you, from the graph we can say for what position the body is in equilibrium or not. If the slope of the graph is 0 for a particular position, for that positions we can say the body is in equilibrium. Now student, this equilibrium are of three types. Number 1, stable equilibrium. Number 2, unstable equilibrium. And number 3, neutral equilibrium. Now see the diagram over here. Now here a ball is situated inside a smooth spherical shell. Okay, and this figure is corresponding to the stable equilibrium. Here the ball is situated over it. Here the ball is situated at the top position of a smooth sphere, and this situation is for the unstable equilibrium. And these situations of the ball over this surface is called neutral equilibrium. Now student, regarding this stable, unstable and neutral equilibrium, you have to remember certain things. whatever may be the type of equilibrium, stable, unstable or neutral, in every types of equilibrium always external force is 0 and du by dr is also 0. Now see the situation of stable equilibrium. F net is equal 0, du by dr is equal 0 and the double differentiation of potential energy with respect to position is positive. With respect to position is positive. And during the stable equilibrium, in the equilibrium position, the potential energy is minimum. You have to remember this. Now, see the situation of unstable equilibrium. Here also net external force 0, du by dr is equal 0 and d2u by dr2, that is double differentiation of potential energy with respect to position is negative, and in the equilibrium position the potential energy is maximum. Potential energy is maximum. And for the neutral equilibrium, the net external force is 0, du by dr is equal 0, and here also d2u by dr2 is equal 0, means the double differentiation of potential energy with respect to position is 0. And the potential energy of the body in the equilibrium position is constant. Now student, see this portion very carefully. On this topic I will provide some important numericals which you have to solve for your NEET and JEE exam. Thank you.